Okay, so in today's lesson, we are going to still work with complex numbers. We are going to be adding them, subtracting them, and multiplying them. Now, some of the multiplication problems will be FOIL questions. Some may just involve distribution. Now, we're also going to learn how to raise I to a power. And we're going to learn how to break that down and find out the value for it. So my first example, if you notice, has a plus sign in between these two complex numbers. So this is telling me that I'm going to add the two complex numbers. Now, before we even begin, generally complex numbers are written in a specific order. And the order is usually the real part of the problem or the number, and then the imaginary or the number that has the letter I. So we're going to write real first, and then it'll be plus or minus depending on the sign on it, and then the imaginary number. So notice both of these complex numbers, they have a real number first and then the imaginary second. The real part first and the imaginary second. And that's how we're going to write our answers. Now, in order to add complex numbers, all I need to do is you can sort of think of like combining like terms. So I'm going to add the two real numbers together, and then I'm going to combine the two imaginary numbers. So I'm going to rewrite my problem and take away the parentheses, and I'm going to highlight my like terms here. So I've got two real numbers here that I can combine. So I'm going to do 3 minus 2, which will give me 1 for my real part. And then I'm going to go and add my imaginaries. Negative 4i plus 6i gives me plus 2i. And I'm done. So you're going to add the real and you're going to add the imaginary or the complex. And this is a complex answer. Number 2, or example 2. Notice the sign in between the complex numbers is a subtraction sign. Before I can begin subtracting, I need to distribute that sign to the second complex number. So I'm going to rewrite my problem distributing the negative sign. So I get 12 minus 5i minus 8 plus 3i, because negative negative becomes positive. So you're sort of doing like a keep, flip, change or a state change. We distribute the negative sign. Now I can go back and add my real pieces. So I'm going to combine 12, which is real, and the negative 8. So 12 minus 8, and I get 4. Now I'm going to go back, get my imaginary, negative 5i plus 3i, and I get negative 2i. And I'm done. So in example 3, I've got multiplication here. I've got two binomials. Okay, they're two complex binomials, but I'm going to FOIL them. So I'm going to do first, and I get 6. Then I do outside, and I get 2 times 4i is 8i. Then I do inside, and I get negative 9i. Get negative 9i. And then finally, last gives me negative 12i squared. Now, does anybody remember what I squared is equivalent to from yesterday? Negative 1. So I'm going to now replace the I squared, and in its place, I'm going to put the negative 1. I can also group those two middle terms. 8 minus 9 is negative I. And then I'm just going to drop down my 6. I can now multiply the black, the negative 12, times negative 1, and I get positive 12. I'll drop down my 6 and my negative I. I now can group the 6 and the 12, so my final answer is 18 minus I. On my next example, I probably shouldn't have given you a head start, but I did. So potentially the problem on the quiz next week is just going to look like this, where it's a binomial squared. Now, when we first took our first quiz, many people messed up on a question like this because they thought they could just distribute the 2 to the 2 terms and that was it. But whenever you have a binomial that is squared, you need to write it twice and you need to FOIL it. So I'm going to FOIL this. So I'm going to do 4 times 4 for my first term. And I get 16. And then I'm going to do outside and I get 12i. And then I'll do inside and also get 12i. And then I'm going to do the last and I get 9i squared. Again, the I squared is going to be replaced with -1. So I'm going to rewrite the 16. I'm going to group the middles. I'm going to take out the I squared, put in a -1, multiply it by the 9. So 16 plus 24i minus 9. And now I can group the first and the last term there and get 7 plus 24i. So on number 5, we're going to FOIL it. It's still multiplication. There's no plus or minus sign in between the parentheses. Now, this is also an example of a complex number and its conjugate. So just like before when we had to rationalize radicals, we're going to have to rationalize a denominator when there's a letter I in there. But this one's still just a FOIL question. So let's just go ahead and focus on the problem we have at hand and we're going to FOIL it. Remember, whenever you multiply something by its conjugate, essentially all we need to do is first and last, but I'm going to do the whole problem just to show you that the outer and the inner will cancel. So 6 times 6 is 36. Outside gives me -30i. Inside gives me +30i. And last gives me -25i squared. So now notice the middle when I group the -30 with the +30i, that will cancel. The I squared again turns into a -1. Notice it's got a subtraction sign there. So when I multiply -25 times -1, that's going to turn into a +25. I still had the 36 here, and then I'll write it here. So 36 plus 25 gives me 61. So whenever you multiply a complex number by its conjugate, you are going to get rid of the i's and it's going to just be an integer. On number 6, what we need to do here is we have a fraction. And in our denominator, I'm seeing the letter I. I cannot leave the letter I in the denominator of a fraction. Just like before we could not leave a radical in the denominator, here we can't leave the letter I. So in order to get rid of that I from the denominator, I have to multiply the top and the bottom by its conjugate. So I'm going to multiply 5 plus I over 5 plus I. And now I have 2 FOIL questions here. I need to FOIL the top and I need to FOIL the bottom. So when I FOIL the top, I'm going to take 3 plus 2i, multiply it with 5 plus I, and I get 15 plus 3i plus 10i plus 2i squared. Again, I'm going to group my middle and take out the I squared. So 15 plus 13i right there, plus 2 times negative 1. So 15 plus 13i minus 2. Group the 15 and the negative 2, and I get 13 plus 13i. That's just the top. I now need to FOIL the denominator. Now, just like we saw in the previous question, we saw that whenever we multiply a complex number by its conjugate, the i's cancel out. And essentially all we're doing here is first and last, but again, I'm going to do the entire FOIL. So first gives me 25, outside gives me plus 5i, inside gives me negative 5i, and last gives me negative I squared. Again, the inside and outside cancel. I'm left with 25 minus negative 1. Be careful on this because you have an I squared that you're putting for negative 1, but you also have the subtraction sign here. So it becomes 25 minus negative 1, which turns into 25 plus 1. So I get 26 for the denominator. So now I'm going to put it all together. So my numerator is 13 plus 13i over 26. I can now simplify all three pieces and divide them all three by 13. So 13 divided by 13 is a 1. 26 divided by 13 is 2. Remember again, the 13 doesn't cancel away. We're dividing it. So our final answer here is going to be 1 plus 1i over 2. And you don't need to write the 1 in front of the I, it's assumed. Number 7. What do you think we need to do to this one? Okay, we're actually just going to multiply it by itself, just like we did with radicals. We're rationalizing here. So I'm just going to multiply the numerator and the denominator by the letter I. So I over I, the top becomes 3i, and the denominator becomes I squared. What is I squared equal? So the top is 3i, the denominator is negative 1. I can simplify that because I can divide 3i by negative 1. So final answer is negative 3i. All right, here we go with number 8 with breaking down I raised to a power. Now, again, there are other techniques out there. I'm going to show you the one that I like. Now, the only thing that we have learned so far is that I squared equals what? Negative 1. This is what we're using. We're going to change our problem to have an I squared in it. So first thing I'm going to write is I squared. I am now going to raise that I squared to a power. I need to find out what I can multiply 2 by to get it as close to 15 as possible. So 2 times what gives me something close to 15? 7. Okay? Now, I've only got 14 i's right now. I still need one more, so I'm going to put times I. Now, someone in my other class asked me, well, this means that there's 15 i's there, right? Why can't I just write 15 i's across my paper and then start multiplying them? You can, but what if I give you a question like I to the 99th power on the test? That would be kind of messy, right? So this is why we're going to use this technique of breaking it down, and we're going to break it down into I squared raised to another power, and if it's an odd number, we're going to have an extra I there. Now, what is I squared equal to? Okay, and then we're going to raise negative 1 to the 7th power. Now, back in Algebra 1, were you ever taught that if you have a negative an odd number of negatives, the answer is always negative. But if you have an even number of negative, it's positive? No? Okay. So let me clarify that. All right. So if you have -1 and it's raised to an odd number exponent, and what I mean by odd number, I'm talking 1, 3, 5, 7, 9, 11, odd numbers. If you have a negative number raised to an odd exponent, then your answer is going to be -1. If your exponent is an even number, the answer is going to be a +1. Okay, so for example, if you had -1 to the 4th power, what that means is -1 times -1 times -1 times -1. And if you take them just 2 at a time, this gives you +1, but then when you do it with this one, it turns negative, and then when you finally do it with this one, it turns positive. So if the exponent is even, 2, 4, 6, 8, 10, something like that, your answer is 1. But if it's odd, it's -1. Now, someone in my other class said, but why can't I look at the problem right when I start and see if it's even or odd? It doesn't work that way. You have to break it down and then look at the exponent that you've gotten when you break it down. So I've broken this one into 2 I squared times 7 and then times I. So 7 is an odd number, so this is -1 times I, and my answer is -I. After you do a couple of these, it'll get easier. Now, I'm going to give you a little heads up. If you see this question on a standardized test or even on the quiz next week, know that I to any exponent, as long as it's positive, your answer choices are going to be only 4. The answer is either going to be a 1, -1, I, or a -I. So if you blank out on the quiz next week and you look at the problem and you're like, I totally forgot, put one of those 4 things on the line. You got 25% chance of guessing and getting it right. But it's not that difficult. We're going to break it into powers of 2 and then look to see if the exponent that we come up with is odd or even. Yes?
Wouldn't it just be +1 because sometimes -1?
Say that again? I's -1. No, I squared is -1.
Oh, yeah.
So that's how I can get an I or a -I. Does that make sense?
Mm-hmm.
So if that was an I squared, then yes, it would be a +1. All right. Now, anybody remember with negative exponents, what happens to it? Goes to the bottom, right? It becomes a fraction. So I'm going to move this whole thing underneath the 1. And now the 3 is positive. I need to break it apart. Remember, you always first start with an I squared. How many I's am I trying to make? 3. Okay, so I've got 2. I need another one. So here's what I have so far. So now I have 1 over I squared is -1 times I. Everybody with me? All right, so if I go ahead and multiply this, and I get -I, I can't leave that I in the denominator, so I need to rationalize. You could also move the negative sign up to the top, but I'll just work with it as is. So I'm going to rationalize by multiplying the top and the bottom by -I. So then I get -I over I squared. And now I squared equals -1. So -I divided by -1 is +I. Number 10, notice the signs in between. And this is a plus sign here. I'm adding and subtracting these complex numbers. So the first thing I'm going to do is rewrite it without parentheses, and I'm also going to distribute the negative sign. So the first one stays exactly how it is. The second one, I need to distribute the sign. So it'll become a -2 minus 3i, and then I'm just going to rewrite the third one. And now I'm going to go back and group my like terms. So I'm going to group my reals. I've got a -4 minus 2 minus 4, giving me -10. Now I'm going to go back and get the imaginaries. -1i, -3i is -4i, plus 5 is just I. And you're done. Number 11, notice there's no sign, so I need to FOIL. So first gives me -8. Outside gives me positive 4i. Inside gives me 12i. And last gives me -6i squared. Again, we need to replace the I squared with -1. I can group the middle terms and get positive 16i. I need to multiply those black terms and get positive 6. Let me rewrite everything else. And now I can group -8 plus 6, and I end up with -2 plus 16i. You're pretty good on 11. Let's try 12. What do I do on something like this? Kimberly? I FOIL. I got to write it 2 times. Excellent. Don't try to just distribute that to exponent. We're writing it out and we're distributing and FOILing. So first gives me 4. Outside gives me 2i. Inside gives me 2i. And last gives me I squared. Again, I'm going to replace I squared with -1. Rewrite the 4, group the 2 middle i's to 4i. And now I can group the red and the black. 4 minus 1 is 3 plus the 4i. Another FOIL question. And on this one, notice they are conjugates. It's a complex number with its conjugate, but I'm going to do it the long way and show you that the outer and the inner will cancel. Now, once you get this down, you don't have to do the whole problem like I've been doing. You can just do the first and the last. But first gives me 36. Outside gives me 24i. Inside gives me -24i. And last gives me -16i squared. I'll rewrite the 36. I'm going to group, or try to group the middles, which they cancel. And then the end, I'm going to do -16 times -1, which gives me plus 16, giving me 52. The next one, it's got an exponent and it's also got a -5 to distribute. I need to follow PEMDAS. So I need to FOIL and do the exponent first. So I'm going to write 4 minus 3i times 4 minus 3i. So I'm foiling first, and I get 16 minus 12i minus 12i plus 9i squared. I'm going to simplify everything down. This turns into 9 times negative 1. So 16 minus 24i minus 9. Simplify the 16 minus 9. And now I have 7 minus 24i. I now need to put it into the parentheses. And I need to distribute. So I cannot distribute first. I need to do the exponent first and FOIL it. So now I'm going to distribute. Negative 5i times 7 is negative 35i. Negative 5i times negative 24i gives me positive 120i squared. Again, the I squared equals negative 1. I will multiply that, and I get negative 120. And now I'm going to write it in the correct form, the real, and then the imaginary. Yes?
Does it matter which way you put it on the test or quiz?
I haven't decided if I'm taking off points. Let's just start good habits now and put real and then imaginary. I'll let you know before the quiz or the test if I will take off points. Now we're going to practice the powers. Last few examples. So number 15, it's raised to the 25th power. So again, remember you're going to start with I squared. We need to figure out what number times 2 will get me close to 25. And that's going to be 12. And 24 times, 2 times 12 is 24. So I need one more I to make it 25. 12 is an even number. So I know my answer here is 1. And first I'll do negative 1 to show you that it becomes negative 1 to the 12th. 12 is even, so it's positive 1 times I gives me I. This time it's to the 26th power. So again, I always start with I squared. So I got to figure out 2 times what is going to get me close to or exactly 26. And that is going to be 13. So negative 1 to the 13th power. It's odd, so it's negative 1. Number 17. It's now raised to the 27th power. So I squared again. Still going to be 13, but this time I need an extra I because 2 times 13 is 26. So again, take out I squared, put in negative 1. Any negative number raised to an odd exponent makes it negative, times I gives me negative I. Number 18. This time we have 32. Start with I squared. 2 times what gives me 32? And notice 16 is even, so my answer is just 1. Then we have one more example, and it's a negative exponent. So remember, we're make it a fraction. So 1 over I to the 10th. Again, start with an I squared. 2 times what gives me 10? 5, and then I replace I squared with -1. 5 is an odd number, so it's -1. 1 divided by -1 is -1. So that concludes lesson or section 3. Your homework again is pages 114 to 115. The instructions say every other odd, starting at 43 through 91, also skipping 81. But I would look at the solution file to get the numbers to work out. Okay, so start at 43, and then it skips 45, 47, and then look at it because it skipped. So look at the solution file to get the numbers to work out. Any questions?